Hi, this exercise we are going to cover how to craft um, a SQL Slammer packet and in a window box as an attacker and launch the Slammer packet um, locally to the Windows and Snort host, IDS host. And the second part of the exercise, we are going to move the attacker to the outside of the network and then exploit the same packet through the firewall, go to the internal target host. A quick introduction for the Slammer. It is one packet. It's a warm virus, and once the packet reached a Windows SQL Server that's not patched, then it will be infected and also self-generate the same packet with the random target IP v4 addresses and send out to the whole internet. So it is powerful. Every second they can self-generate thousands of Slammer packet and send it out as if they are the attacker. And the unpatched server will be infected right away and then doing exactly the same thing to affect other unpatched Windows SQL Server. So the whole world, when it was launched, within about 10 minutes or less, all the unpatched Windows SQL Server were affected. The document is listed here under SQL Slammer Packet Craft attack on the Linux and Windows IDS IPS host. So you can download this document, open it up, and then watch the video and complete the exercise on the Monset VMware. Once you open the document, we're going to quickly go through that. The objectives of the exercise are actually for us to familiar with how to craft a packet. And then during the crafting of the packet, we will have to put in certain MAC address, IP addresses, host destination at least, and that information. The packet already has all the signature and payload to trigger a signature for the Slammer. But we do have to put in the correct MAC address and IP addresses so that the packet can be delivered from the tester to the target host. And we have already learned that during the first part of the course. And the first part is that we are going to put the 2016, which is the one that we are going to craft the packet. You can call this a tester or the attacker. The first one is they are going to use the Windows 2016 has two NIC cards, one connected to outside 10.10.10 and one connected to the inside. And the inside is 10.01 network. So first exercise, we are going to enable Windows inside and give it an IP address, and then so bypass the firewall and do a local to local attack. And then we will figure out what kind of MAC address, what kind of IP address can we or should we use. And second part is we're going to move it outside and then do exactly the same test. Second objective for this exercise is to understand, to write, to get familiar with how to update the binary snort rules. And we will write it in both the Linux snort and the Windows snort. Windows snort, I already create a snapshot, and that's in the Windows 10 box, which we did in the previous exercise. The third objective is to explore and investigate and discuss how can we mitigate this kind of attack, in addition to the defense in depth DID concept that we talked about last time. We are going to first power on the Windows Linux, the Linux Snort box, and also the Windows 10 Snort. And also we are going to power on 2016. And we have some overhead here to actually activate the Linux, which we did also in the last exercise. So I'm going to start a hands-on and put a document on the side. If you need internet access, you have to power on internet firewall. And we will need the pfSense net for the assessment from the outside. We moved the 2016 the tester outside of the network to test to send the SQL virus to the internal Linux and also the Windows Snort. So we need Windows 10, we need Windows Snort, and we need Windows 2016, and we need pfSense. Let's go to the Windows 10 first. Right-click and you take a look at the snapshot and look at the snapshot manager. And last week we actually rolled it back and then installed the whole thing. And this week it already been moved back for you in here. It's already have both the batch for the snort created for you in here. Okay. The Linux snort, once you log in as root, and you're going to log in as using the password. The password has been documented on the week 1 for all the virtual boxes. If you need to go back and review it. The first part of the exercise, we have to go to click on the Red Hat and go to the system settings, go to the network, and then make sure that we edit the Ethernet and hardware device. We are going to prompt it. And once we prompt it, then we are going to activate. And once we activate it, then it will be ready. And we can actually come here, open the box and do an ifconfig. And then you will make sure that your IP 10.01.4 is already up. Okay, so we're going to move this on the side. And after we've done that, we can run one box. We call it we are going to open 3 of the terminals. One we can run snort, and we call it MySQL. And you can do Control-C to break it if you want to do that. You can do MyTail, MyTail, in any place, and then it will be showing you the log for the ending, the log file. We have done that in the previous exercise. And of course, in here, you can use MySnort to activate that. Before we do that, we need to add the new binary-based SQLSlammer rule into your SQL rules. And the location of that is cd /etc snort and other rules. Okay. And if you don't know which directory you are in, type in pwd, print working directory. So if you do an ls, and you will see that all the raw file is in here. So what we would do is we're going to do a gedit, gedit, and then SQL.rules. Okay. So it's been documented on your handout. And you have to put in this line to save the recording time. I already punched it in. So you're going to put in this line, which is also documented in your handout here. We open the terminal, use the gedit to edit the file SQL rule here. Remember, the blue one is the syntax. Okay, so once you put this signature in, this rule contains a binary signature inside in the packet. The quote and with the vertical bar means that this is binary. Okay, so it's the binary number of C050 FF16, and with all this number in there, if these bytes are found in the packet, then trigger the ID 1,000,007 and give out the message. I put down Jim so I can identify it. You can put your name here, Jim Slammer Warm 7. So I always use a 7 for this one. For a reason, we will know pretty quick. And then after that, you can click File and save and exit. Once we've done that, we can actually type in my snort here. Already did. And make sure there's no error. So that's okay. With this, that means it's listening. So we're okay with it. We move this to the side, and you are looking at the log. So we're done with that. Now we are going to go to the window box and to do the same thing. In the window, in the previous week, okay, we already install it, and we create the similar batch. And we create a batch with a name called MySnort with a capital A. You can use a lowercase a, it wouldn't make a difference because Windows is not case sensitive in the command. And this batch file, it will just run the command of snort-I space 1 space -c space location of the configuration file. And capital A means that, hey, put all the output into the console, the text output. So the alert, the IDS under the Windows Snort log is not going to log the text-based information. However, the attack packet, once it's been triggered, then it will be logged in the log directory. And we can use the Wireshark to open the offending packet to analyze what's going on. So we go into the window box, and if we take a look at it, we can take a look at the file. It's in C drive, Windows, System 32. It's the MySnort.a. This is the batch file that's been created during our last exercise. And save a snapshot so you don't have to recreate that again. To activate it, then we can just go to the command prompt here, and we're going to take a look at, we're going to call it the MySnort. You can call it anywhere else because it's in the path of the search path in here. So now we're going to go back to using the Explorer to take a look at the structure. C drive, and it's been installed to Snort. And then there are rule here, and we're going to have to put in the same rule into the SQLSlammer rule. Okay, so we can also going to take a look at the log. So there is a log file in here, and you can see that, oh, okay. Once you activate your Snort, it's going to create a new file here for you. And this is the June 16th when I was doing the imaging. So this is the existing old log, and this is a new log, and you can see the current date has been created. Okay. Okay, so we go to the rule folders and find the SQL rule. Right-clicked, and then we can edit with the Notepad++. That's what we did last time. And we don't have to update it. So we're going to put the rule in here. You can type it in, or because this is a window box, if you download it in your host, you can just go ahead and highlight it. Okay. And right-clicked, Copy. And let's see if we can copy and paste. So sometimes you have to open either Notepad or Notepad++, and then paste it into it from your host. And then just do another step of copy and paste, and it should work. So let's see if it's already in there. Okay, so paste it in. It is alert from any external net, any port to the home net, which is any, and then go to a destination of the SQL port, and then call it Slammer 17. Okay, and you can put your name in the front if you want to identify it. And then content is the signature of the virus and the ID and the revision. Okay, and after that we have to save it. File and let's save, and then let's reduce it. And at the point we can actually we have to control break to terminate it, because the rule, in order for it to kick in, you have to update the rule first and then run the program of my snort. And then we are going to go back to the snort and look at the log file. Okay, so it's got created here. Now we're ready to launch the Slammer and craft the Slammer packet. So we already up to the step of in the Windows 10, we updated to the SQL rules, and it's similar to typing those commands. If you don't want to run mysnort A, you can type it in. It will produce the same result. But remember though, if you update any rule file, for it to kick in, you have to edit the rule first before you run the snort. And now we're going to do the local exploit. Okay, in the Windows 2016. We are going to, the ones already pre-downloaded, and also it's also in the Canvas, the week of this exercise, that you can download the CPB, the Colasoft packet builder, or you can download from the internet. We're going to import a Slammer packet, and later on when we cover Wireshark, I'll show you how to export, find the packet from a file that's with thousands of packets, find a Slammer packet and export it out. Once you can export, and today the input is pretty simple. We just use the CPB and then open the packet, import the packet, that's it. So now we are going to first change the destination MAC address to broadcast address. And then the source, we're going to just change the last digit. So we know that we are forging the source, the sender, and see if that will work. And also put the broadcast so that everyone on the same local area network will receive a packet, okay? And then after that, we are going to highlight the packet, and then we're going to click send, and we're going to send it just 5 times and click on the start. And then we check the result, and the result should be like this. So we are going to perform this part of the exercise. So now we are going to go to the Windows 2016. And log in. Password is changing me. And you can see that the CPB is already being pre-installed here, so we don't have to install it again. Double click on that, and you will see this familiar screen here. Now we're going to click on File and we're going to click on import. And it's already been downloaded for you, the Slammer packet in here, and also the ICMP packet. We're going to skip the ICMP portion of the exercise today. And you open it up, and this is a single packet, so you can only see one packet in here. And you can see that this is the place where I want you to change it. So FF. So that's a broadcast. And it will change it to capitals, okay? And in here, we are going to just change the last one to, it's Windows 2016. So I'll put down 16 here. So you knew that this is not the true MAC address of the Windows 16 anyways. But after changing it, you can be assured that this is definitely not the true MAC address of the attacker. So once this is done, you can actually click on the checksum if you want to make sure. And then you're going to click on here, the packet. And then once you click that, the sending is available. So you click on the send, click on here on the loop, and let's just send it out 3 times. Good enough. And we say start, and it's going to send it out. And if we take a look at the Windows 10, you'll see that, hey, yeah, you have something to trigger in here. And you can see this from and if you follow it so far, then you're going to see that it doesn't actually produce any results as what we expected. That's because I actually forgot to update the Windows 2016's IP address from the inside. So it's not actually generating the attack that we are anticipating. So we are going to go here and we are going to highlight and so open the Network Share Center. Now we're going to change the adapter settings. First thing first, we have to change the inside. Right click and we're going to enable it. And we're going to look at the property, look at IPv4, and we're going to change that to 16 for sure. Otherwise, you will lose the internet and you will DOS ourselves because it's the same as your default gateway. And we can use Google as our so you can just enable it after you update it instead of enable it first. Should not matter. And in the outside, we look at the property and IPv4. It really didn't matter. We use 244, so you can change it to 244. So now when this is done, then let's take a look at it. To make the exercise more specific, we can go to the step setting here, because we're not doing the outside test now, so we can actually disable it so that we make sure that all of the packet has been sent out from the inside interface. All right, now we're going to reduce it. Okay, and let's close this one for now and take a look at the adapter. So if you take a look at the adapter, there's only one virtual adapter. Whether you assign it for inside or outside, this one it sees only one of them, and you see that's 10.01.16, which is okay, which is acceptable. Now we click on here, and we're going to send again. And this time, let's make sure the IP should be 140.144. It's the old Monsec old classroom's IP address. So this should be used as the trigger for the Slammer packet. So we're going to send it. We're going to send it 3 times. Make it 5 times. Start, and then we go to the Linux, and you can see that, okay, it got triggered now. All right. So you get quite a few of those triggered, and you go to your window box, and you will see, okay, now it got a trigger. So you got the Slammer Worm 7. That's the one that we put in. And you also have the other one that triggers, but it's the 9, which is the one I put it into the ICMP .info rule, okay? ICMP info.rules. And so I want you to, in the exercise, I would like you to take that one out so that you can actually modify your rules by adding and by deleting, okay? So in this snore box, you can also go in there to edit it. So we're going to Control C. We don't have to break it out because we have opened a few boxes here. And we're going to go to gedit, ICMP dash info. So once we get in there, you can see, oh, okay, ICMP info rule, we do have one in here as well. This is the one. Highlight from top. And this is the one that we wanted to delete it. Okay. And once we delete it, go ahead and save it. And if you do that, it will still show up. The rep3 will be still showing up because it you have to break out of here. You have to break out of the snort. And then run the snort again. So then the new rule will kick in. So we're going to move it a little bit bigger. Okay, fixing it out as well. So we'd like to see it in one line so you can drag it a little bit bigger. My tail. Okay, so we just wait for it. And in the Windows 10, well, I'm just going to skip it. We'll just look at the Linux box and take a look at it. So now let's look at the procedure here. We did trigger all those redundant rules that I already put it in. And so I'd like you to actually delete one of them and then repeat the exercise. So you're going to delete the file, delete the ICMP info rule, and take this one out. And in the Windows 10, you take the other one out. We're going to skip Windows 10 in the demo. You can do it or you can skip it. And then we're going to run an attack again to verify they are both gone. In the window place, in the Linux, you can also use mytail, or you can go to the location of the log and then type in the grab to grab whatever is slammer in the particular file to see that. Or you can say cat to type in everything in the log, and then you're going to grab whatever's in the slammer. But look at mytail is enough for this exercise. And from there, we're going to open the Windows 10. We're going to focus on open up the attack packet, okay, and examine that. And of course, you can spoof the IP address to broadcast. That's the step after that. So we're going to move this on the side, and we're going to launch the attack again. So we're going back to our Windows 16. And in this time, we don't really have to do anything because we just updated the snort rule. So you can attack it again. I think I already did. Just want to make sure I run it again. So go to the Linux, and you can see that, okay, yeah, Jim Slammer 7 now. So the other one is gone. But we did trigger some of the built-in rule that's actually not the same. There's a different revision that's come with the snore box, okay? And so the one that we edited, the 1,000,006 revision 3, my slammer is gone, the one that we deleted. So just want you to get familiar with how to add and how to delete a rule to see the message in there. Now we're going to Windows 10 and to All right, so Slammer does pops up, and then we're going to open this box. All right, in here. So this is today's log. If I clicked, and we can open with Wireshark, and more apps actually is in the Wireshark folder, and Wireshark ESE. So it's under program files, Wireshark in here. Or you can go to a desktop to open Wireshark and go to the folder to open it. Either way is fine. So once we open the log file, and you can see that, okay, it does capture quite a few of those packets. And this is the one. You can see I used this is actually a forged or unrelated source address and destination, but because it is a broadcast, so everybody receive a copy. And so to illustrate the concept that if in the same network and you use the broadcast FFFF address in here, and you can forge whatever the MAC address in here, then the switch is a layer 2 box. It doesn't understand anything else. If you look at the FFFF as a destination, it's going to, just like an ARP broadcast, it's going to send it to every single host. And if your host is an IDS and you look at and examine the packet, then it matched the rule, and that's why it got triggered. And the packet will be logged into the snore log. So if you take a look at that, single packet, you click that packet, and you can see that this is the whole packet inside here. I'm going to move it up a little bit and save some viewing space here. If you click on, we are going to spend 1 week talking about Wireshark. So this is a quick preview. If you click the whole frame, you see the whole thing got highlighted. And you click on layer 2, and this is a layer 2 got highlighted. You got a source and destination MAC. And you can see that if you open it, destination go first. So that's why it's FFFF first. Now this, and then you look at the IP layer, so 20 byte. You can count it as total exactly 20. It's 2 plus 16 plus 2, the minimum size of IPv3. And then there's a UDP and TCP UDP, and this is a UDP, and it has total of 8 bytes. And then it's the data payload. And this one is actually the vulnerability code in here. So if we take a look at the handout again in here. So I calculated out here for you that we have total length is 418. And 418 minus layer 2 MAC address 14 byte, right? Source destination and the type field minus the IP layer 3 20 byte minus the UDP 8 byte 376, which is a data payload. It's starting from the 43rd byte highlighted here, starting from 04. So this is the virus code in here. And you can actually, one of the discussions asking you to find a signature. So you can find a signature and do your screenshot and point it to that place. So after that, we're going to spoof the destination to 255.255.255 and repeat the test. And it should produce exactly the same result, okay? So we can go to 2016 here again, and we have to close it. And this time, we're going to just come here. And this is a source, and this is a destination. So you can actually use 255. Okay. In here, and go to the window 10 here. Let's exit it out of here. And then we can reduce it. We can actually control break. All right. Now we can activate that again. And we're go back to the 2016, and we can again click on the checksum and click on the packet. Once you click packet, the send is available, and come here and launch it. Another few times, start, and now we're going back to Windows 10. We'll see if it shows up. Let's look at the LinuxSnort, and LinuxSnort box actually got recreated again in here. Let's see. The 255, it doesn't seem like it triggered that, so let's take a look at it. SQLSlammer, so let's try that again. Okay, so seems like the window box is just taking a little bit long time for it to actually show the log file in here. So if it doesn't actually show right away, just make sure that we give it a little bit of time, or try to do a Control-C to break it out and try to redo it, and you will see that, yeah, destination is in here. And then in the Snort Linux box, you can take a look at it, and you can see that, yeah, from the 221 to the broadcast address, it also got locked. So we know that it worked in this particular settings. The setting was the broadcast on the MAC address and the broadcast on the destination. It produced the same result. Now at the CBT, we already finished this spoofing of the destination and repeat, and it does produce the same result. And the local area network ordinary switch belongs to the layer 2, and it really doesn't care about your layer 3 information. It could be a DHCP broadcast, it could be an RIP version 2 or version 1 broadcast. It just go ahead and, according to the MAC address, send it out. The IP3 layer 3 information doesn't play anything on the switch. And when the packet reached the snort, then they will analyze what's been received, and it will log it accordingly. So that concludes our first part of the exercise. And now we are going to start it to perform the exploit through the remote network. So we have to go to the Windows 2016 to disable the inside and set the outside address and perform the same attack. Okay. So now we go to the 2016. This is the 2016. And let's go to our, reduce that. Go to our network and go to our adapter settings here. Now we are going to disable our inside. And the outside, we are going to enable it. So we just move, we did move, but then we actually put this attacker to the outside now. And take a look at the IP address of the attacker. In the IPv4 here, look at the property, it's 244, and default gateway is 10.10.10.10, which is okay. Right. Now let's exit it out, and let's go back to the Colasoft. And you can double check on the adapter again. Well, so now this time it can tell you that it's 10.10.10.244, and still it's the same Intel adapter that's been used. Default gateway is like that. Now we are still going to do the broadcast, the same thing, and we just leave this alone. And now we are going to run the test. Again, let's go to the Snort box, and let's break it out, and let's run it again so we can easily identify. Now see if it got triggered again. And then Windows 10 box, we can just leave it alone like this. We can tell it's from 255, 255, 255 here if the new one are generated. Okay, so we're going to the Windows 16. And we're going to launch it again. Send. Okay, once you send it, then the Snowbox doesn't receive anything. Your window box shouldn't receive anything. The reason is, if we take a look at the 2016 here, let's take a look at the topology here. Now, when we send from here and we use a broadcast, it will send it to here. Send it to everyone still, the same thing, just like if we did it inside. The problem is, a firewall, it will not forward the packet in for a broadcast message. In addition to that, the destination here is using broadcast. None of the firewall will forward the broadcast information to it. So we have to change the destination IP address. It has to be specific. It has to go to the translated address of the inside host so that it will have a chance to be forwarded back. So we are going to do that. That's why it failed, because we use a broadcast address, and none of the firewall or security appliances will forward any broadcast message to the internal host. None of them will do that. So now we're going to go in here and we're going to change it, close it. Another thing is, let's just follow the logic here. So we go to step number 12. So we go through the logic first, and then I'll do the demo. The exploit will be failed because the pfSense firewall will not forward any broadcast MAC address over. And then we're going to change the destination to pfSense's MAC address so that we make sure that, hey, so what we will do is we are going to change the destination MAC address to the pfSense MAC address because we need to forward the attack packet to the pfSense. That's the first step, and specifically for the pfSense. And we also, whether it's the original image of the destination 140, 144, 235, 250, or the broadcast address of 255, 255, 255, it's not going to work. You have to use the translated address of 10.10.10.4. For the window, it will be 10.10.10.220. So we're going to fix those two and see if it will be activated. Right. So in here, first we have to find out what is the MAC address of that. You can do an ARP-A to find it, and 10.10.10.10 is our default gateway. So we didn't even see 10.10.10.53. So we're going to ping 10.10.10.53, which is the pfSense's outside connection. And pfSense 53 is the one that we need to send the packet to so that it can possibly forward it. If the packet passed the translation and passed the ACL, the access control, then it will be forwarded to the target. Now, if you do, after you ping it, you take a look at it, you will see the 53 now is in your MAC address cache. Click here and let's go edit and mark. We are going to highlight this one. Okay. And we're going to copy. Now we're done with that, and we can just use a notepad. We need to make it easier because the two programs use different separator. So you have to use the column here. So this is the MAC address for the pfSense outside. We're going to right click, we're going to copy it again, put this in here in case we need to do it again. And we are going to find the destination here and Control V. So we put in the MAC address. We still can forge our address, MAC address. It wouldn't matter because it's a UDP packet. We don't need a connection, and it's only take one packet to do the job, to attack it. And you can see that we can change this destination again to 140.144.235.250, just like the document say, or if your image has been reset to original stage, then this will be the original IP packet, IP address. And I can tell you it's not going to work because your destination is to 140.144, and the pfSense doesn't even know what that is. So it's not going to forward it back to the inside. Okay. So again, we can actually check that. But this time, let's just change it to the destination to the Linux box 10.10.10.4. Okay, that's the translated address of the Linux box. So let's take a look at the Linux box here. Linux Snort. All right, so it's here, nothing in the Slammer. And we're going to the window 10 here. We're going to the attacker, to the 16. And now we're ready to launch it. And this time we forge it to here. And we can also forge it to Google 8.8.8.8. May as well just do that because it's the same thing. Whether you use 140.144, the one that no one knows what that is, I can also put it as a Google. I'll try to attack you. So we put the destination MAC address of the true real address of the pfSense outside. So the packet will be delivered to it. And we'll tell them that, hey, who is it for? It is for 10.10.10.4. And pfSense says, yeah, that's the one I translated from 10.01.4, the Linux Snort to the outside. So yes, and my ACL permitted. So good, I'll forward it over to here. Then your Linux Snort has been attacked, and it will be locked with the attack message. So checksum and click on this packet and send. Do exactly the same thing. And let's start the attack 5 times. Now we go to Snort, and you can see that, okay, now we got the, okay, so if everything works smoothly, you're going to see that 8.8.8.8 now send it to 10.01.4 has been locked because it's 2016 in here. So close that. So it's from the source of 8.8.8.8 and ping 10.10.10.4. And we use the true MAC address of the pfSense's outside IP. And if you ping it, you can see, if you ping the 10.10.10.4, you'll be able to see that 10.10.10.4 is in here. Actually, it's the same as the 10.10.10.53. It's all pfSense's outside. If it doesn't work, that's because sometimes those system crash. It happened to me first time though. Then all you have to do is you actually can go back to roll back into your Windows 2016 right clicked and go to your snapshot manager and go ahead and you can click it in here and you can just highlight this one, the latest one, and then double click it and say yes. So it will roll back to your beginning stage. And after that, you can again import a packet, and all we change here on this exercise is just we have to update it to the true MAC address of the pfSense outside, and we still can forge the MAC address, and then we can on the destination we have to use the true number, and you can forge the sender with 8.8.8.8, and it will be locked in your Snort in here. 8888. Okay. Now we're going to complete it with, we change that to window box, which is the 210. And we're going to, again, click on the checksum, click on the checkbox, and send. And we are going to look and 4 times. Okay, if you see it kind of slow in the delay, with the delay, that means it's working fine. If you just go ahead and zoom through it, there's something wrong with it. Okay, so you might have to roll back. And after that, then you can see that, well, we got quite a few messages, but you can see that Slammer 1 already again got triggered, and you can see Google 8888 is the offender here. Okay, so for the exploit, we are talking about G now. For the exploit to work on the remote network, the PFSense MAC address must be used as the destination MAC address, and translated either the Linux or Windows Snort IP also must be used so that it will be forwarded by the PFSense to the inside host. And here's the explanation on that. And they both lock the 8888 as an offender. So now let's do the conclusion and summary. On the same network, broadcast address MAC in the packet builder, it will send the craft packet to every host. So if you use the unicast, then you must use the real MAC address of the target you want to send. We use FFFF, meaning broadcast. That's why in a local attack, everybody receive it, including the Windows, including the Linux. And if you want to target to one particular host, then you have to use the unicast address that really matching the target. The number 2, the source MAC address and the source IP address and destination IP address, it really doesn't matter because it only requires one packet, and this UDP doesn't require any connection. Be aware that the attacker's MAC address IP can all be forged on both scenarios. Okay, so we do not, I don't want to steal the other day's topic, but I just have to mention it right now that we do not retaliate. We definitely don't retaliate the attacker because it could be forged, okay? And then we are not going to just go and block it because it's 8888 is a Google DNS server. If you're inside, then what happened to use the 8888 as your DNS, then we might have just disabled ourselves, DOS ourselves. So we'll talk about that some other time. Now, there are a few methods to mitigate the attack. You can use the MAC address filtering on a switch so that we cannot let anyone to forge their MAC address. So at least you have the accountability. Once you locked it in there, you knew that the MAC address is true MAC address that's been used to launch the attack. And Cisco has some of the switch commands, switch port security, and you set a specific MAC address. Be aware though that once you tighten it up, you can't have any, if you replace the box, the MAC address doesn't match, then it will not be working. You have to update your switch again for it to work. So security and convenience doesn't usually go together. It usually go the opposite way. Now, of course, we can deploy and enforce this physical security and put a cage to lock the computer too. So that's in addition to avoid the situation where some employee just bringing in their own personal device and plug it into your network. And this also happened to the wireless as well too. You don't want to have a very secure system in a firewall in the gateway, but then you allow the system to employees to bring their notebook and go to take a lunch outdoor, and then start working on it, and then sign on to your network and go out without you even allowing it. So we have to pay attention to that. And we also tighten the user's desktop so that they can actually download any tool like CPT, as like a packet crafter type of tool to experiment or intentionally do some damage. And of course, we implement the defense in depth and many other different security measurements. The measures such as antivirus and others other security application and softwares. So now we talk about the remote network, the broadcast MAC address in a packet crafter. It will send the still the crafted packet to every outside local host. But most of the security appliances is not going to forward it because the security reason, let alone that the IP address doesn't even matching specifically for the translated address of the security appliances. The source MAC address and IP address really doesn't matter. So this is the true for both inside and outside attack. And the most important thing is to know that not all the attacks has this kind of characteristics. This is because the slammer it's a UDP and it's only require one packet. So it doesn't require any connection to constantly send the information back and forth to compromise, to exploit the victim. The destination MAC address must match the security appliance's outside MAC address. And the destination also must match the victim's translated address. So the security appliance will receive a packet and then possibly forward the packet to the target host for your access to take effect. And also understand that the attacker's MAC address, IP address always can be forged. Okay, and the countermeasure is pretty much the same. Okay, so this is the end of our exercise.